Hey everyone, welcome back to another fun and exciting Algebra 2 class. Today we're going to just jump right back into where we were in lesson 7.2. We left off on page 335 in the last lesson. This lesson hopefully will be a little bit shorter than the last lesson, but we are going to be talking in this lesson about the graphing and translation of the exponential functions. Alright, so if you look down at the screen, we'll kind of get right into it. The standard form of the exponential function is right there on your screen. What you're going to do is you're going to have the function of x, okay, because that's what makes it a function. You have the function of x, and then this is the standard form of that. A, b, and then the exponent is going to be the x. Remember, that's the what we don't know, minus h plus k. Now this should look somewhat familiar to you. We have done that with the standard form of our quadratic equation when we were graphing parabolas and things like that. So what we do is remember some of the pieces to that. Some of the pieces to that was this a right here was very important. This negative h is very important. And this k is also very important. So let's talk about what those three things do, and they're going to be almost identical to what they do in the other ones, in the quadratic ones that we've already talked about. So let's look down here. The k is the vertical translation. What does that mean? K moves it up and down. So this piece over here at the end, this k, and a k is going to be a number. All right, it's not going to be a k, it's going to be a number. A 7, a 3, a -5, something. K is going to be a number, and k is going to move it. What does k do? Well, if k is positive, then it translates up. If k is negative, then it's going to translate it down. Okay, so based on what k does, positive or negative, that's going to tell you whether or not this exponential function, when it's on the graph, is going to be moving up or down. The next piece to this is the h. And if you remember, the h is a little bit tricky. I'll go over there and pull that part in too. The h is the horizontal translation. That means it's going left and right. Okay? And remember, the h has a negative sign attached to it, and that's the same as in the other one that we've already talked about as well. So when the h is positive, it actually translates to the left. When the h is negative, it translates to the right. Now, since the formula has an h with a negative sign, it seems to defy the sign. In other words, it seems to go backwards. In other words, let's say my h equals 3. Well, that 3 is actually going to translate to the left. Why? Because it's got a negative sign with it. Whereas if h equals -3, that is going to translate to the right. Why? Because it's going to be negative, negative, and then the formula is going to make it a positive. So that's a little trick right there. Remember that. That defies logically what you're thinking. You typically think, okay, positive goes to the right, negative goes to the left, but this is going to be opposite. When the h is positive, it's going to go to the left. When the h is negative, it's going to translate to the right. All right, the next one is the a. So what happens here with the a? This one is a little bit complicated, and so let's talk about the different pieces to this. If the absolute value of a, or if a is positive, we'll put it that way. Okay, so if a is positive and it's greater than 1, then it's a stretch. It stretches it up. If the absolute value of a, or if a is positive and it is less than 1, okay, so it's a fraction, something like that, or a decimal, then it's going to compress. It's going to push down. Okay. Now, compression is different than translation. Translation just means the whole thing moves up. Stretching means it's actually like pulling it up. Okay, or pushing. Compression means it's pushing it down. Translation means the whole thing moves. Compression and stretch means the whole thing is stretching up or compressing down, but the whole thing is moving, rather than in translation where it's like you just take it and you just like you take the picture of it. It's what's called a rigid transformation, so it's rigid. The whole thing moves. Non-rigid is the A, and that's meaning that it's compressing or stretching. Now, the other thing that the A can do is when the A is negative, it's going to reflect vertically. Or in other words, and we did this with parabolas, if the parabola is going up, when the A is negative, it reflects it back down. Okay? And, we've talked about that quite a bit, about the reflection principle there. All right. One new concept that we need to add here in this section is what's called the asymptote. The asymptote. Now, here's what that means. This is when the line is approaching another line. Let me show you the difference between the exponential function and the quadratic function. In the quadratic function, remember, we had a parabola. It looked like a U shape. These exponential functions are just going to be a flat curve. Now here's the difference. We had a line, that was a line graph, and then we had and I don't know if you can see that. Let me change the color so you can see it a little bit better. All right, so we had a line graph. And then the other one that we had a parabola. Now, notice what's going on here with the exponential. It's almost like a combination of the two. It's kind of like a straight line, but then it kind of curves like the parabola. So it's almost like you're getting that you're taking the two things and you're mixing them together, which is really what you're doing. Okay, so you're taking the straight line and you're curving the line up like you would with a parabola. Now, that's the exponent. So this curve right here that you're looking at, this is the exponential curve. Now, there's something very interesting about an exponential curve. The exponential curve, like for instance, this C right here, this is the asymptote. Now, this blue line will never touch that C line. Why is that? Well, because let's say this is a 2 to the x, no matter what you put in there, okay, no matter what you put in there, it will not reach 0. You cannot make this number go to 0 with an exponent. Can't do it. Because if you put 0 as the exponent, it still equals 1. If you put a negative as the exponent, it continues to come close to 0, but it will never reach 0. You can keep trying and trying and trying, and it will never reach 0. Why? Because you're always multiplying it times something, times itself. It's always a multiplier. Even if you're multiplying it times a negative, which is making it get smaller, it can never, ever reach 0. And what that looks like on the graph is it looks like this right here, where it's coming close to the line, but then it never touches the line. So that line is called the asymptote. So the curve approaches it, doesn't touch it, comes really, really close. And the farther up we go, like if we kept going up with that, it would keep getting closer and closer and closer until it was microscopic. But it will never, ever touch that line. Okay, it can't touch the line. That's called the asymptote. And that is on page number 335. 335. If you read that, translating graphs of exponential functions, if you read that little section, you'll see that there where it talks about the asymptotes. Okay? All right. Let's go ahead and let's try one of these. I told you I was going to try to make this a little bit shorter lesson, so let's do that. Let's just, since we've already really kind of talked a lot about the translations in the other section of the book, let's just kind of do one and see how that goes. Let's jump to the hardest one that they give you. Let's not mess around here. Let's go to page number 338 and let's look at letter D. Example letter D. And here it is. The function of x equals 1/2 times 7 to the x plus 9 minus 2. Well, really the key here is that we have to remember what is the parent, what is the standard form. So let's go ahead and take this standard form, really just this part's the part we're worried about, and let's write it down there so that we can reference it. So we have AB to the x minus h. AB to the x minus h plus k. All right, so there's our standard form. Each one of those things does something else. I'll continue to go back up and we'll look at this and we'll try to figure out what this thing is doing. So let's first of all identify. What is that? Okay, well that is the A. That is the A. So we have the A is going to be 1/2. A equals 1/2. What's the B? Well, the B is the base. Now, we don't use the base, but let's identify the base. The base is a 7. That's our base. And then we have to the x, and the x is just x. We won't write that one in. And then the h. Now, it's negative h. Be careful. I'm actually going to write that. Negative h equals, what's our negative h? It's 9, positive 9. And then our k is right here, and our k is the negative 2. So our k equals negative 2. So let's talk about what this thing is doing. Let's talk about where the movement is going to be on the graph. What kind of translation are we looking at? All right, so let's look up there, and let's start with the k. That's where we started with the explanation. So it says k is the vertical translation. So a positive k is going to move it up, and a negative k is going to move it down. So let's go down here, and we have a negative k. So that's going to be moving down. How many spots? 2 spots. I say spots, 2 lines, 2 grids, 2 places on your Cartesian plane. All right, so that's the k. What was next? We did the h next. This is the horizontal translation. When h is positive, it translates left. What was our h? Our h was actually positive 9. Okay, so if you go back up here, our h was positive 9. So remember, because the formula, the original formula, had a negative, here's that negative right there, it's actually going to go backwards. So let's go back and look. When h is positive, it translates left. So our h is 9, so we're going to go left 9 spots. Okay. What's our b? Our b is just our base, so that one's not going to translate it, but that's the base that we're dealing with. And I'll show you a little bit more later about what we're going to do with that base. But for right now, we'll just leave it alone, and then we'll tackle that a equals 1/2. So what does the a equal? Okay, ooh, that one had lots of stuff going on with it. So a equals 1/2. Is absolute value of a positive? Yes. So we're not going to worry about this. So it's not negative. Is the absolute value of a greater than 1? No. So we're not going to worry about that. It is less than 1. It's 1/2. 1/2 is less than 1. So the absolute value is less than 1/2. So we're going to have a vertical compression. So it's going to compress by, let's see, compress, I can do this, by 1/2. And what that is that's a multiplier. So if you remember this from the section on the quadratics, what that's going to do is that depending on how much you're multiplying by, it's going to either stretch it by 3, 4, 5, the bigger the number, the more the stretch, or it's going to compress it more. So this is a 1/2 compression, and as we're graphing, we would adjust our graph based on that compression. Okay? And so that's how you do that. That you just isolate what is A, what is your base, what is your H, what is your K, and then that tells you how you're going to graph it. I'm not going to actually take the time on the video here to do one of the graphs, but you know how to count 9 spots to the left, you know how to count 2 spots down, and then you should know how to do the compression. Basically, the compression means we're going to multiply this whole thing, if you will. We're going to multiply this whole thing by, or we're going to distribute that 1/2 to everything. and so it's going to reduce everything by 1/2, and when you reduce it, it shrinks it down, it compresses it down. So that's what the 1/2 does. Okay? Alrighty, well, if you missed anything there, I know I talked a little bit fast, but I tried to make it a little bit quicker video. Go back, rewind it, and see what you missed. Hopefully you learned something today. If you have any questions, you can always just drop them there in the comments, and I can try to help you out with that. All right, we'll see you later. Have a good one. Bye-bye.